Today we're going to do a little bit of review on slope. Now, you've seen slope before, so hopefully this is just going to be a refresher. Well, slope, when we deal with lines, is when we talk about what's called the rise over the run. The rise is going up, the run is horizontal movement. Now, the rise can be up or down, the run can be left or right. Another way to think of this is the change in the y's divided by the change in the x. We're going to look at the slope in two different ways. The first way is going to be looking at the graphs. So let's take a look at number one. For the following graphs, find the slope. Simplify any fractions. So we want to know how quickly this line is going up, or if it's going down, how quickly it is going down. One of the best ways to do this is to pick out a point on the line that we can easily find. And this might be a little bit tricky here, but I think, you know what, this point right here is a good one. And then where else does it cross a nice intersection? And it looks like about right here. So with graphs, one of the things we can do is we can find the rise over the run. Well, we're starting from this point and we're going to go to the right a certain distance and then up a certain distance. The question is, what is our run and what is our rise? Well, let's start with the rise. From this line we went up 1, 2. So the rise is 2. And the run is 1, 2, 3, or 3 to the right. So our slope, we have a rise of 2 and a run of 3. So our slope of this line is 2/3. Okay? Now, if we want to see if that actually works, we can go to the right 3 more. 1, 2, 3, and up 2. And we better be at another point, and we are. So there are ways that we can check our slopes, and it's always a good suggestion to do that. Now, one of the other things we should pay attention to is the intervals. We want to make sure that our intervals on the x and y are the same distance. What I mean by intervals is this line is 1, that's 1 more, that's 1 more. Same thing with the y's. They go up by 1s. If they're different in any way, you have to be careful and keep track of how much that distance is. Okay? Let's take a look at our next question. So here we go. We have another nice clean point right here. If we didn't, we could have picked out some other points. So I'm going to start with this one right here. And then when do I have a nice other intersection? It looks like not until all the way up here. So how do I get from this point to this point? Well, it looks like I'm going to go that distance to the right and this distance up. The question is, how much is that? Well, 1, 2 you might say, but this is actually going by 10, so 10, 20. So 20 to the right and 10, 20, 30, 40 up. So our slope is really 40 up and 20 to the right. Now we can reduce that and we get a nice slope of 2. But always pay attention to the actual distances. Now, if you do notice, we could have said 2 to the right and 4 up, and then did 4 over 2, which would have given us the same answer. But you have to be careful again. If these intervals are not the same, the x intervals are going by 10s and the y intervals are going by 10s. If they're not the same, then you actually have to count this distance. So be mindful of that when you're doing these problems. What if they don't give you a graph, though? Let's scroll down and take a look at these here. Now, find the slope of a line passing through the given points. So let's think about this again. Slope is the change in y divided by the change in x. It almost looks like I don't have a g here, does it? Ha ha. Now, another way to think of this is when we have points, we have two different points. We'll call this one x1 and y1, meaning our first x and our first y. This is our second x and our second y. So the change in y is really subtracting the y's, or y2 minus y1, And the change in x is subtracting your x's. It doesn't matter if it's y2 minus y1 or y1 minus y2. This is just a standard way we write this. So if we use this formula to find our slope, we can take our second y, or 2, minus our first y of 14, divided by our second x of 6, minus our first x of 9. We could have put 9 minus 6 here, but if we did that, we'd have to do 14 minus 2. So make sure whichever point you choose to put first, the x's and y's have to come first in that case. Now, if we subtract this, 2 minus 14 is negative 12, and 6 minus 9 is negative 3. Negative 12 minus, or negative 12 divided by negative 3 is positive 4. So our slope of this point that goes through these points, the slope of the line that goes through these points, is 4, even without seeing it. But we could graph it just to check. Let's try one more. So again, slope equals, I'm going to label again, x1, y1, x2, y2. Okay? How about what would happen if we put these first? How about negative 5 minus, now what are we subtracting? Negative 14. Be careful with that. I see a lot of people write, oops, that looks like 19. Let's try this again. This really should be a 14. Okay, so be careful. I see a lot of people do negative 5 and then minus 14, but it's really minus negative 14. So watch your signs. Over 4 minus, what are we subtracting? We're subtracting negative 11. Now we have two negatives together, that becomes a plus, so it's negative 5 plus 14 divided by 4 plus 11. Negative 5 plus 14 is 9, divided by 4 plus 11 is 15, and we can reduce those. 3 goes into both those. 3 goes into 9 3 times, and 3 goes into 15 5 times. So our slope of this problem is 3/5. And there we have it. Two different ways to find slopes, either by the graph or by the points. Good luck with your problems that you have to do.